Let's take a look at A-Levels 2023 H2 Math Paper 1. And in question number 1 over here, we are supposed to find the exact equation of the tangent to the curve, where the equation is given to us and it is going to be at this point when x is equal to 2. So in order for us to find the equation of the tangent, we need some pieces of information about this tangent, which is a line. So what we need will be the point, a point that is on this line, on this tangent. And we know that the x-coordinate of this point can be 2, which is given to us by the question. And we also need the gradient of this line, the gradient of the tangent. So if we are given that the equation of this curve is ln y is equal to 11 minus 5x squared, in order for us to find the gradient, let's try to do an implicit differentiation to this to get a dy dx. So on the left-hand side, we have a 1 over y dy dx. This is equal to 11 minus 5x to the power of 1 and minus 5. So dy dx here is going to be equal to negative 10y 11 minus 5x. And we are supposed to be finding the equation of the tangent when x is equal to 2. So when x is equal to 2, the corresponding y coordinate of this point can be found through this equation. So substituting this back, it is going to be ln y is equal to 11 minus 5 times 2. So 11 minus 10 is going to be 1. 1 squared is going to be 1. So we have a ln y is equal to 1. This tells us that y is going to be equal to e. So on this hypothetical line, which represent the tangent to the curve at the point 2, we know that there is this point that is going to be of coordinates of 2e. And one more piece of information will be for us to find the gradient of this line. So to find the gradient of this line, it is through dy dx. When x is equal to 2, y is equal to e. Let's substitute into here. So from here, dy dx is equal to minus 10y, which is e, then 11 minus 5 times of 2. So it's going to be 1 here again. So the gradient here is going to be negative 10e. So now we can find the equation of the tangent. And this will be y minus the y coordinate of a point that is on the line, which is e, then is equal to the gradient minus 10e, then x minus away the x coordinate of the same point that is on this line. So from here, we will get y is equal to negative 10ex plus 21e. And in question number 2, we have a series and sequence question. In question number 2, we have a term un, and this is in a cubic polynomial form in terms of n. So we are going to just write un, because according to the question, it is a cubic polynomial. So we will write this as an to the power of 3 plus bn squared plus cn plus d. This will be a cubic polynomial. We are going to try to find un in part A, where we are given 4 pieces of information. The first one is u1 is equal to 10, which means that we have a times of 1 to the power of 3, b times of 1 squared, c times of 1 plus d. This is equal to 10, so we have a plus b plus c plus d is equal to 10. This forms for us our first equation. The next piece of information that is given to us is u2 is equal to 61. So we have a times of 2 to the power of 3 plus b times of 2 squared, c times of 2 plus d. This is equal to 61. We have 8a plus 4b plus 2c plus d. This is 61. This gives us equation number 2. And u3 is given to us as 206. So again, using this, u3 will be a 3 to the power of 3, b 3 squared, c times 3 plus d. This is equal to 206. And we have a 27a. So here is a 27a plus 9b plus 3c plus d. This is equal to 206. This will form for us our third equation. And the last piece of information that is given to us is U4 is equal to 469. So it will be A times of 4 to the power 3, B times of 4 squared, C times of 4 plus D. This is equal to 469. And we will have a 64A plus 16B, 4C plus D. This is 469. This will form for us our fourth equation. We have 4 equations with 4 unknowns A, B, C, D. We are going to just use our graphing calculator to solve for this system of linear equation. So from our graphing calculator, we will be able to get the values of A, B, C. Let me write it down. A is going to be equal to 4. B is 23. C is negative 46. And D is 29. So now we have the expression for UN. UN will be A, which is 4, n to the power 3, plus B, which is 23, n squared, plus C, which is negative 46, then n plus D. This is 29. This will be for part A, and in part B, we are supposed to find the range of values of n, for which UN is supposed to be greater than 25000. So UN is this, 4n to the power 3 plus 23n squared minus 46n plus 49. This is bigger than 25000. We're going to try to solve this inequality for the range of values of the n that the question requires. So I'm going to bring this over to the left-hand side, which will give us a 4n to the power 3, 23n squared minus 46n. This will be minus 24871. This is bigger than 0. And I'm going to press this into my graphing calculator again to generate a table to analyze what are the values of n such that this expression is bigger than 0. And we are choosing to use a table because n is the nth term, un term. Okay, so we are expecting it to be an integer value. So for this, from the table, we will be looking at all the different values of n, and the calculator will be generating for me the corresponding value of this. Let me write it down as the header here. So this to the power 3, 23n squared minus 46n minus 24871. Scrolling down the table in our calculator, you will realize that when n is equal to 16, this is negative 3335. This is not positive yet. When it is 17, this is 646. This is the first time when this expression becomes positive. And when it is 18, it is going to continue to be positive, 5081. So from here, we know that n is going to be from 17 onwards. So we are going to write down the range of values of n. And because n is an integer value, let me just write it down for this range of values of n, right? Such that we are looking at only integers, okay? So n are integers such that n is supposed to be bigger or equal to 17. Okay, let's look at the next question. Okay, in question number 3, we are looking at a vectors question. We are given that a dot b is equal to -1, and we are also given that a cross b plus a is perpendicular to a cross b plus b. And we're supposed to make use of these few pieces of information to try to show that modulus of a cross b is equal to 1. So I think I'm going to start off by making use of this piece of information here. So this will be when a cross b plus a. This is perpendicular to a cross b plus b. So since they are perpendicular, when I dot the two vectors, they should be equal to, the result should be equal to 0. Let's try continue from here, and we will be expecting ourselves to be applying quite a few of the dot product and cross product algebra. So let me just switch to a table which we have in our outline to just help us to take a look at which are the properties that we're going to be using. So let me look at this table that we have here on our Achevas outline. So the first thing is I'm going to try to expand this by applying number 5 over here. So this will be this, it will be A cross B, and this dot this, A cross B. Then this, it will be plus A cross B dot B, then this will be plus A dot A cross B, then this is plus A dot B. This is equal to 0. And we have one vector dot another vector. According to what we have here in number 2, one vector dot another vector is modulus of that vector square. So this dot this is going to be modulus of A cross B square. As for this, A cross B is going to be giving us a vector that is perpendicular to both A and B at the same time. So if this is perpendicular to A and B at the same time, this dot B should be equal to 0. The same goes for this. This dot this should also be equal to 0. As for this, it is given to us by the question as -1. So I'm going to just replace this by -1. This is equal to 0. Let's go back to the question. So we have this as -1. Yep, that is what I've written. So we have this square is equal to this. So we will have a modulus of A cross B square is equal to 1. So modulus of A cross B, this is just going to be equal to 1, which is what the question wants us to show. And in part B, we are going to try find the angle between A and B, vectors A and B. Okay, so we have actually two pieces of information that can bring in angle that is going to be between these two vectors. I'm going to let the angle be theta. And the first piece of information I'm going to make use of will be this. A dot B is equal to -1. Let me write it down. A dot B, this is equal to -1. And if I were to let the angle that is between the two vectors be theta, that means modulus of A, modulus of B, cosine theta, this is equal to -1. Another piece of information I'm going to make use of will be this that we have shown in the previous part, where we have a modulus of A cross B, this is equal to 1. And if again, I'm going to make use of what we have here, number 1 here shows that A cross B is the same as modulus of A, modulus of B sine theta, and this is equal to 1. So according to what the question wants, we are supposed to find the value of theta. And if I were to call this equation number 1, and I call this equation number 2, by taking equation number 2 divide by equation number 1, we will have a modulus of A, modulus of B, sine theta, divided by modulus of A, modulus of B, cosine theta, which is equal to 1 over -1. And this can be cancelled. Sine over cosine is tangent. So we have a tangent theta is equal to -1. And the angle that we are working on is going to be between 0 to 180 degrees. So we are looking at our first and the second quadrant. Tangent of an angle is equal to negative, so it is going to be in the second quadrant, which means that theta here is going to be equal to 180 degrees minus away the basic angle, which is going to be tangent inverse of +1. So it will be 180 degrees minus 45 degrees. My answer here is 135 degrees. Okay, now let's take a look at question number 4, where in part A, we are supposed to integrate cosine px, cosine qx. And this is not an expression that we can integrate directly. So what we are going to try to do is to refer to what we have in our formula sheet under trigonometric identities. And let's see whether we can convert these to expressions that we can actually integrate. So if I were to look at what we have in our formula sheet, and looking at this and comparing to what we have in our formula sheet, this is a cosine multiplied by cosine, and in our formula sheet, we have a cosine multiplied by cosine here. Let me just rewrite this on the board, and let's see how we can make use of that to try to re-express this integral. Okay, so from our formula sheet, we have this cosine p plus cosine q. This is 2 cosine half p plus q. Then cosine half p minus q. And what I am going to try do is I'm going to try to let this expression here, this expression that is within cosine, I'm going to try to let this angle that is within cosine here, I'll try to let this angle be A, and I'll let this angle be B. And if you can just observe together with me, if I were to just try to do an a plus b, then it is going to be a half p plus q, then plus half p minus q. And what we will be getting is half p plus half p, which is going to be equal to p, then half q minus half q, which will be 0. So p is equal to a plus b. And that means this is actually a plus b. We're going to do likewise to a minus b. And if you can observe together with me, what will a minus b become? It is going to be this minus away half p minus q. And it is going to be half p minus half p, which will be 0. Then we will have a half q minus half q, which will become half q plus half q. This will become q. So this q here is actually a minus b, where a is this and b is this. So now we can actually re-express on the right-hand side, on the left-hand side. Let me just write. We will have a cosine a plus b and plus a cosine a minus b. And on the right-hand side, this, I will just rewrite it as a, and this, I am going to rewrite it as b. And now we have another trigonometric identity that we have come up with that will be able to help me to re-express cosine a times cosine b into a form that is like this. And that is what I'm going to try to apply here. So for this particular question, now making use of this new trigonometric identity that I have come up with what we need will be a coefficient of 2 in front so that I can simulate this. Okay, so this is going to be equal to half integration of 2. Then cosine px, cosine qx. And half, I'll just let it remain. And for here, I'm going to now re-express into a form that is like this. So a, b will be this px, qx, which means that it is going to become cosine a plus b. And here it will become cosine of px plus qx, which will be p plus qx as that angle. Then plus cosine a minus b. In this case, it's going to be cosine px minus qx. So it will be cosine p minus qx, and this will be the other angle. And what we have now within cosine function is just a linear expression, and that we can integrate. So this is going to be equal to half. If I were to be integrating this will be a sine p plus q. This is the angle. And I'll divide by the coefficient of x, since this is just a linear expression. Then plus, this will be sine, then p minus q, and I will divide it by the coefficient of x, which is p minus q. So now, this is going to be the expression that will be the integrated form for part A. Let's take a look at part B. So for part B of the question, we are going to do another round of integration, and we are supposed to be integrating x, cosine, and x. Okay, we are going to integrate this. And in order for us to be integrating this, we will need to make use of the integration by parts, because we have one function multiplied by another function, where this function, I'm going to see it as belonging to the category of algebraic expression, and this is definitely trigonometric expression, because we are going to be applying LIATE for me to decide on which is the term that I'm going to be assigning to in the integration by parts process. So for u, I'm going to assign a to it. Okay, a comes before t. So u, I'm going to assign x to it, and dv dx, I'm going to assign the other one, which is this. So du dx, this is equal to 1, and v, this is equal to sine nx over n. Okay, now we are ready to do an integration by parts by re-expressing this using this that we have came up with. So it is going to be uv, so it will be this times this, which will be x sine nx over n, minus integration of v times du dx. This is just 1, so it will just be a sine nx over n. And this is actually pretty easy to integrate. In fact, I think I'm going to just factorize out this n for now. So we will have 1 over n, and here it is just going to be a sine nx. Okay, now this is like really easy to integrate. So this is going to be x sine nx over n minus 1 over n. Integrating this is going to be minus cosine nx over n. And let's not forget about the plus c. We're supposed to show the expression that the question requires us to show, and I think we have gotten that because this is just x sine nx over n. So it is the first expression the question requested us. And the next one is going to be minus times minus, so it will be plus. And here we have a cosine nx over n squared plus c. Okay, done. Part B. And for part C and part D, we will be making use of the previous part of the question, which is actually part B of the question. So let me just rewrite the result of B as I erase the board, back here on top. Okay, now let's take a look at part C when we are going to be making use of the result that we have shown in part B. So by making use of the previous result, we are going to now evaluate this definite integral, which is integrating from 0 to pi of the same expression that we have here. So it is x cosine nx dx. We are supposed to evaluate this, expressing it into the form of a constant k over n squared, where possible values of k are supposed to be determined. So we will be expecting more than one possible value for k. So let's try to make use of the previous result, which means that it is going to be x sine nx over n plus cosine nx over n squared, integrating from 0 to pi. Let's not forget about the information about this n. Okay, according to what the question says, n, this n here, right, they are positive integers. So let me just write it down. N here belongs to positive integer. Okay, it is mentioned to us by the question. And let's try to make use of this additional information to try to substitute the lower and upper limits in and see how far we can evaluate it. So this is going to be equal to pi, then sine n pi over n plus cosine n pi over n squared. So this will be the first expression, minus away. Oh, this is just going to be 0. Okay, I'm going to still just write first. So we have a 0 sine 0 divided by n plus cosine 0 over n squared. Okay, so we will have this. And for this, sine a positive integer of pi is going to be equal to 0 all the time. So here it's going to be 0 plus cosine n pi. I'm going to just let cosine pi be cosine n pi. Later we're going to try to analyze its value together. So this will be cosine n pi over n squared for now. This is definitely going to be 0. And for cosine 0, this is going to be 1. So we have a 1 over n squared. So what we have now will be a cosine n pi over n squared minus 1 over n squared. So I'm going to factorize out 1 over n squared, which will then give me a cosine n pi minus 1 within the bracket here. And now let's analyze cosine n pi. Because n is a positive integer, so for example, when n is equal to 1, then we will have a cosine pi. If n is equal to 2, then we will have a cosine 2 pi, which means that it will be cosine 3 pi, cosine 4 pi, and all the way. Cosine pi, it is going to be equal to minus 1. And cosine 2 pi is going to be 1. 3 pi is going to be equal to minus 1. This is going to be equal to 1. So it is just going to be alternating between the two values, plus and minus 1, which means that we will have two possible cases. One will be n squared. This can be a minus 1. Or the other case can be 1 over n squared, where this can be a plus 1. So it will be 1 minus 1. So what we have here is going to be now a minus 2 over n squared or 0 over n squared. And now we are seeing two forms that are the same as the one that is given to us by the question, where it is going to be a k over n squared. And k is the value to be determined, So therefore, we know that k is either going to be equal to -2 or k is going to be equal to 0. This is going to be for part C. Let's look at the next one, part D, where we are going to be integrating this again, but this time with a modulus. So now we are going to be doing part D instead of C, where the integral that I'm supposed to be doing is from a lower limit of 0 to an upper limit of pi over 2. And we are looking at this expression to be x cosine 2x. So n here is going to be replaced by 2. And we are going to be integrating this with a modulus notation that is given. So we want to find the result for this. Okay, and the question says we want to find the exact result. Of course, we can still press into our calculator later to do a quick check and verification. But let's try to just integrate it from with all the exact values for now, okay? The first thing that we should do when we are trying to integrate something with a modulus is we should try to draw the graph of the expression that is inside here. So for example, if I were to draw the graph, I can try to draw the graph of y is equal to x cosine 2x first, okay, without the modulus. And from my graphing calculator, the graph of this will look like this. Okay, let's say this is the x-axis and here is the y-axis. We will have a graph that looks something like this. Okay, that represent this. And we are looking at only the region that is from 0 to pi over 2. 0 is going to be here and pi over 2 is here. Okay, here is pi over 2 and here is actually a pi over 4. Because you have to let this be equal to 0, then you can work out this value, okay, pi over 4. So we have something that is like this, and with a modulus, we know that this portion is going to be reflected about the x-axis. So if I were to look at the graph of y is equal to the modulus of x cosine 2x, then the graph is going to be definitely similar to this. If I were to just sketch the portion that is from 0 to pi over 2, it is this portion is going to remain as here, okay, from 0 to pi over 4, and this portion is going to be reflected, so we will have a region that is something like this, and pi over 2, let's say it is still going to be here. So we are looking at this area here that will be numerically representing this. So what we can do is we will see this portion of the graph, as the original one. So this portion of the graph will be represented by y is equal to x cosine 2x. And as for this portion of the graph, it is the reflected portion. So for this portion of the graph, I'm going to see it as y is equal to minus x cosine 2x. So now I can re-express this according to our analysis. We will first look at this as this portion here. So it is going to be from 0 to pi over 4. Okay, and that will be just us integrating x cosine 2x. Then the other region, it is going to be us integrating from pi over 4 to pi over 2 for this graph instead. So it's going to be from pi over 4 to pi over 2, and it is going to be a minus x cosine 2x dx. Okay, so this will represent this. Let's just move this negative out. So that will be a negative here, and here it is going to be removed. And in order for us to be integrating this, we are once again going to make use of the previous result. It is going to be equal to, for this, it is going to be x sine, in this case, n is going to become 2, right? So I'll replace this n by 2. So we have a 2x over 2 plus cosine 2x over 2 squared from 0 to pi over 4. Then minus away this region over here, this integral over here, and it is still going to be x sine 2x over 2 plus cosine 2x over 2 squared. And it is going to be from pi over 4 all the way until pi over 2. Let's do the substitution. It is a bit tedious. Okay, so this is going to be substituting this in. We have a pi over 4. Then sine 2 times of this pi over 2 over 2. Plus here we will have a cosine pi over 2 over 2 square, or I can just write it as 4. So we will have this minus away, substituting 0 in, it is going to be just 0 in the numerator, so 0 over 2. Then plus we will have a cosine 0 over 2 square. Okay, this is going to be for the first integral. And as for the second one, it is going to be substituting this in, we will have a pi over 2 sine pi over 2. Then plus here, we will have a cosine pi over 2 square. Okay, this is when we substitute pi over 2 in, minus away, substituting pi over 4 in, it is going to be pi over 4 sine pi over 2 over 2. Then plus cosine pi over 2 over 2 square. Okay, we have a few trigonometric functions to try to evaluate. This here is going to be equal to 1. This is going to be equal to 0. Cosine 0, this is going to be equal to 1. Sine pi, this is going to be equal to 0. Cosine pi, this is minus 1. And this is equal to 1. And this is going to be equal to 0. And if you were to just evaluate them, this is going to be pi over 8 plus 0. Then this is going to be 0 plus 1 over 4. Then minus away, this is going to be 0, then minus 1 over 4. Then minus away, this is 1, so we have pi over 8 plus 0. And evaluating this, you'll get a final answer as pi over 4. And like what I was saying just now, after you've gotten this answer, maybe you can just do a quick verification by just pressing this into your calculator directly, just to verify that numerically it is going to give you the same value as pi divided by 4. Let's move on. Let's take a look at the next question, question number 5, which is a summation question. Okay, let's take a look at question number 5 here. It is a summation question, where in part A, we are supposed to be making use of the method of difference to try to evaluate this summation, summing from r is equal to 2 all the way until n of the logarithmic function of r minus 1, r plus 1 over r squared. If I were to just expand the sigma notation based on this expression that we are given, we'll probably find it difficult to apply any differences. So we should try to manipulate this first before we actually try to see whether we can find any differences and patterns that we can follow so that we can apply this method of difference. So I'm going to try to apply the law of logarithmic function to try to re-express this as a ln of r minus 1 plus ln of r plus 1 minus away ln of r squared. And for ln of r squared, these two, I can bring it forward. So I'm going to just do that. And we will have this. Now let's try to expand this. And let's see whether we can get some differences that will be appearing in the form of a pattern. Then we can apply this method of difference. So when r is equal to 2, we will have a ln 1 plus ln 3 minus 2 ln 2. When r is equal to 3, it is going to be a ln 2 plus ln 4 minus 2 ln 3. We're not seeing anything that is actually that cancelable yet, although this and this looks the same, this and this looks the same also. Let's just write down one more row and let's see how it goes. So that will be when r is equal to 2, 3, 4. So when r is equal to 4, we will have a ln 3 plus ln 5 minus 2 ln 4. I think we can probably do some cancellations already because this is minus 2 ln 3, this is plus ln 3 ln 3. So this can be cancelled. Let's just write down one more row to see whether this cancellation can be repeated. Okay, so one more row, that will be when r is equal to 5, and this will be ln 4 plus ln 6 minus 2 ln 5. And we are seeing the same cancellation happening as a repeated cancellation with the same pattern, because like what I've shown you just now, this ln 3 here, this can be cancelled, right? And if you were to consolidate all the ln 4 that we are seeing so far, ln 4 plus ln 4 minus 2 ln 4. So this will also disappear. So we are seeing a pattern. Most likely it is going to be propagated all the way. So let's just try to write down, since 3 row gives us 1 cancellation, let's try to write down the last 3 row to just do a quick verification that this pattern is going to continue all the way until even the last 3 rows. So for the last 3 rows, that will be when r is equal to n minus 2. So this is going to be ln of n minus 3 plus ln of n minus 1 minus 2 ln of n minus 2. Then when r is equal to n minus 1, this will be ln of n minus 2. Then it will be plus ln of n minus 2 ln of n minus 1. One last row, that will be when r is equal to n. This will be ln of n minus 1 plus ln of n plus 1 minus 2 ln n. Let's see whether we can get the same pattern of cancellation. And yes, we do, because if I were to be consolidating ln n minus 1. So we have a ln n minus 1 plus ln n minus 1 minus 2 ln n minus 1. So this will be cancelled, which means that in between terms, this will be cancelled, this will be cancelled. In between terms, this will be cancelled, this will be cancelled, this will be cancelled. I'm going to be left with this, and here, here, and here. Let's try to consolidate all this together. Hopefully we can show what the question wants us to show. So this is going to be a ln 1, which will become 0 in a short while. Then we will have a minus 2 ln 2 plus ln 2, and then a plus ln n plus ln n plus 1 minus 2 ln n. So this will become 0. Here we will have a minus ln 2 plus, this is going to be a ln n plus 1, because ln n minus 2 ln n will be minus ln n. And yep, I think we are getting what we want already, because this plus this is going to be a ln this minus this. It will be a ln n plus 1 over n, and this is according to what the question wants us to be showing, and then minus ln 2. Okay, so we have shown what the question wants us to show, and in the next part, we are supposed to show that the corresponding infinite series is convergent. So we are looking at a case where this is going to be summed to infinity, so n will go to infinity. Let's try to do a discussion, which is when n goes to infinity. Okay, when n goes to infinity, this is going to be evaluated into this, where n goes to infinity here. So let me just discuss about this part. Okay, because this is the only part that is in the entire evaluated expression that will be affected when n goes to infinity. So for this, we are going to be looking at ln of n plus 1 over n. So when n goes to infinity, basically the numerator and the denominator of the expression inside ln, they are both going to be going to infinity. We cannot make any decision. Okay, so I'm going to do a small little manipulation to this, which is a super easy manipulation. N divided by n is 1. Then we have a 1 over n, which means that when n goes to infinity, this term will become 0. We will be getting just a ln 1 plus 0, which is going to be ln 1, which means that this will become a 0. So it becomes a finite value. Therefore, we can say that the series, the infinite series, is convergent. Therefore, let me just write it down. The infinite series that we are given by the question is going to be convergent. Okay, and we want to state this evaluated sum to infinity. So that will be us trying to sum from r is equal to 2 all the way until infinity of ln of this r minus 1, r plus 1 over r squared. And this is, when this becomes 0, I'm going to be left with just negative ln 2. So my answer here is basically just negative ln 2. Okay, next, C, we are going to try to evaluate this sum from r is equal to 10 all the way until 20. of exactly the same expression that we have there, which is going to be ln r minus 1 r plus 1 over r squared. So we are definitely going to be making use of the previous result that we have here. And in order for me to make use of the previous result, I'm going to start from 2, just like this. This n can be replaced by any constants. So I'm going to start from 2, ending at 20 of ln r minus 1 r plus 1 over r squared. Then I will minus away, summing from r is equal to 2 all the way until 9. Okay, 2 to 20 minus away 2 to 9, it will leave me with 10 all the way until 20. So ln of r minus 1 r plus 1 over r squared. Now I can make use of the previous result. So for the previous result, n is going to be replaced by 20 here. So it's going to be ln 20 plus 1 over 20 minus ln 2. Minus away, n is going to be replaced by 9. So it will be ln 9 plus 1 over 9 minus ln 2. Minus ln 2 plus ln 2, it will disappear. So I will be just left with 21 over 20 within the logarithmic function. And here is going to be 10 over 9. So this is going to be a ln of 20 over 21 over 20 over 10 over 9. My answer here is going to be a ln of 189 over 200. So we have just shown the format that the question wants us to show, where according to the format that the question says a and b are supposed to be integers to be determined. So therefore, a is going to be equal to 189 and b is going to be equal to 200. Okay? Okay, let's move on some more. Let's take a look at question number 6. Let's take a look at question number 6 now. This question number 6 here, we have a trigonometric identity proving in the first part, followed by an integration for volume in the second part. So for part 1, we are supposed to show the identity. And what I think we should do is start from the side that looks a little bit more complicated, and that is the right-hand side. So I'm going to start with the right-hand side, which is equal to 1 over 8 cosine 4 theta plus 4 cosine 2 theta plus 3. And the question requires us to use the double angle formula. Again, let's take a look at what we have in our formula sheet. And to use double angle formula, I think we are going to try to use cosine 2a is equal to 2 cosine square a minus 1. Because by doing that, we can actually re-express this here into a 2 cosine square 2 theta minus 1 plus 4 cosine 2 theta plus 3. Okay, then we will have at least consistently a cosine 2 theta. So this is equal to 1 over 8, and we will have a 2 cosine square 2 theta. So here square 2 theta plus 4 cosine 2 theta and plus 2. Okay, I mean, let's factorize out 2 and then simplify it together with this. Will give us a 1/4. And this will leave me with a cosine square 2 theta plus 2 cosine 2 theta plus 1. In fact, we can actually factorize this. Let's do that. So we have a 1/4. Factorizing this will give me a cosine 2 theta plus 1. The whole thing square. And with this that we have here, we are going to try to make use of this again, because cosine 2 theta, let me just write it down, because cosine 2 theta is equal to 2 cosine square theta minus 1 as written here in our formula sheet. So if we were to be trying to prove what the question is trying to ask us to show, which is going to be cosine to the power of 4, then this, I'm going to just bring this plus 1 over minus 1 to the left hand side, which will give us a cosine 2 theta plus 1 is 2 cosine square theta. And now I can very easily replace this here, and we should be getting a cosine to the power of 4. So this is going to be 1/4. Then this is going to be 2 cosine square theta square, which will be 1/4. This is going to be 4 cosine 4 theta, power 4 theta. So we have a cosine to the power of 4 theta. This is equal to the right-hand side. And this is what the question wants us to show. And we are probably going to be making use of this to help us in our integration later. Let's see whether it is going to be happening. So for part B, we are going to try to find the volume that is revolved when this region R, so the volume that is going to be generated when this region R is rotated about the x-axis, entirely about the x-axis 2 pi radians, according to what the question says. And this region R lies in the first quadrant, and it is bounded by the curve y to the power of 4 is equal to 9 minus x squared to the power of 3. And the two vertical lines, x is equal to 1.5 and x is equal to 3. So if we were to have a y to the power of 4, which is equal to 9 minus x squared to the power of 3, we want to try to see this curve so that I can have a better understanding of how the region looks like. And that will help me to write down the integral. So to do that, we are going to try to make use of our graphing calculator, but too bad, this is not a function. Okay, so it is going to fail the vertical line test. We can't use the function feature that is on our calculator. So what I think we can try do is to power 1/4 on both sides, which gives us a plus minus, then 9 minus x squared to the power of 3/4. So if I were to plug this into my graphing calculator, I'll be plotting this as two curves. One will be y is equal to 9 minus x squared, the whole thing to the power of 3/4. Then the second one will be y is equal to minus 9 minus x squared to the power of 3/4. And when you plug this into the calculator, what you are going to be seeing will be you getting two graphs. One will be this. Okay, and this will be for this part. The other one is going to be this. And this is going to be for the other part, the negative version. And we are looking at the region that is going to be lying in the first quadrant. So it is going to be here. So if I were to use my graphing calculator, after drawing it, what I want to do is to transfer the related graph onto my script so that I can see exactly which is the region that we are going to be integrating with respect to. So that will be this region over here. Let me just draw a portion of the graph. Okay, maybe I should just draw the whole thing. Okay, so it is going to be something that is like this, where here it can be a solid dot. Here it can also, it should be a solid dot. Here will be minus 3 and 3, because if I were to let y equal to 0, when x is equal to plus or minus 3, then y is going to become 0. So the region that we are talking about is the region that is going to be bounded by this portion of the graph, which is y is equal to positive 9 minus x squared to the power of 3/4 from x is equal to 1.5, half of this. So around here, 1.5, all the way until 3. So we are looking at this region that is going to be rotated by 2 pi radians about the x-axis, which means that the volume that is going to be generated will be us integrating from 1.5 all the way until 3. Pi should be outside here, and we are going to take this 9 minus x squared to the power of 3/4. We are going to square this. Okay, so this is going to be the integral that will represent the volume that is going to be generated when this region is rotated by 2 pi about the x-axis. And according to what the question says, right, we are going to be making use of the substitution expression. So let me just simplify this a tiny little bit. This is going to be pi integrating from 1.5 all the way until 3 of 9 minus x squared. 3/4 times 2 is going to be 3/2. And the substitution expression that is given to us is x is equal to 3 sine theta. So when x is equal to 3 sine theta, what we will need in order for us to replace all this x over here will be dx d theta, which is going to be 3 cosine theta. We will also need to replace this. So when x is equal to 1.5, then 3 sine theta is equal to 1.5, which means that sine theta is going to be equal to half. this tells us that theta is going to be equal to pi over 6. I'm going to just do the replacement as we try to write down this, okay? So this will be pi 1.5 is now going to be replaced by pi over 6. I'm going to replace this x is equal to 3. So when x is equal to 3, so 3 sine theta is equal to 3. This tells us that sine theta is going to be equal to 1. This is easy. So theta is going to be equal to pi over 2. So this 3 will be replaced by pi over 2. Then we will have a 9 minus x squared. So this square is going to be a 9 sine square theta to the power of 3 over 2. dx we will be replacing, and that will be a 3 cosine theta d theta. Okay, so let's see how we can integrate this further, but at the same time, we should be expecting that somehow along the way, we will be using part A's result. So this is going to be equal to, I'm going to factorize out 9. Pi over 6, pi over 2. If I were to factorize out 9, it will be 9 to the power of 3 over 2. We will be left with a 1 minus sine square theta, the whole thing to the power of 3 over 2. Then we have a 3 cosine theta d theta. 3 times 9 to the power of 3 over 2 is 81. So this is going to be 81 pi, integrating from pi over 6 all the way until pi over 2 of this multiplied by this. And for what we have here, 1 minus sine square theta is going to be cosine square theta. So it will be a cosine square theta to the power of 3 over 2. It is going to be cosine to the power of 3 theta times cosine theta. That will give us a cosine to the power of 4 theta. Okay, so this times this is going to be a cosine to the power of 4 theta d theta. And I guess this is the time that I'm going to just go all the way back to part A to make use of part A's result. Because as it is, I'm pretty sure we cannot be integrating this, okay, according to what we have learned in our syllabus. So this is going to be 81 pi integrating from pi over 6 all the way until pi over 2. This, let me just replace. I'm going to replace it by 1 over 8 cosine 4 theta plus 4 cosine 2 theta plus 3. Okay, this is definitely possible for us to be integrating. So let me write it down here. 1 over 8, let me take it out. So it will be 81 pi over 8. And we will be integrating cosine 4 theta. Cosine 4 theta, integrating it is going to be a sine 4 theta over 4. Then this is going to be plus 4 times of sine 2 theta over 2, then plus 3 theta from pi over 6 all the way until pi over 2. And I'm running out of space. Okay, so it is going to be equal to 81 pi over 8. And substituting this in, we will have a sine of 2 pi over 4. Then plus, this is 2 sine 2 theta. So substituting this, we will have a 2 sine pi. Then plus, this is going to be 3 pi over 2. So we will have this minus away, substituting this in. It is going to be a sine 2 pi over 3 over 4 plus 2 sine pi over 3, then plus pi over 2. Okay, and this is going to be the second expression. Okay, so we know that this sine 2 pi is going to be 0. Sine pi, this is going to be equal to 0. Sine 2 pi over 3, this is going to be square root of 3 over 2. And this sine pi over 3 will also be square root of 3 over 2. So if you were to evaluate this, okay, then you will be getting the answer. Let me just write down the answer. The answer is going to be equal to 81 over 8 pi of pi minus 9 square root of 3 over 8. Okay, it is actually not too bad. It's just that my board is a little bit small, but okay, this is a tiny little bit tedious, but it's not such a bad question. Let's move on. Let's take a look at the next one.
Question 7. The function f is defined by fx equals to modulus of 2x plus 4 divided by 3 minus x. Part A. Sketch the graph of y equals to fx, giving the equation of any asymptotes and the coordinates of the points where the curve meets the axis. So let me just sketch it with my GC. And I have a graph here, and I'm going to transfer that diagram onto this board here for question part A. I'm going to first put in the asymptotes. I have asymptote at y equals to 2, and I also have asymptote of x equals to 3. And next, I'm going to just put a shape in here. And the last thing I'm going to do is to write down these coordinates. And also this one here. That's it for part A. Part B of this question. Hence state the range of f. Now let's take a look at the minimum. So it's this point here. So we have the range of f. Minimum is at 0. And the maximum of this graph goes to infinity. So we have the range of f from 0 to infinity. Part C. Explain why the function f squared does not exist. Let me write down the function here. We have x squared x, which is also equals to f(x). We're going to look at the range of the first function, f. Let me just write down range of f, transferring this information here. Next, we'll take a look at the domain of the second function. We're going to look at this one here. Domain of f is going to be from negative infinity to 3. So I have negative infinity to 3, union with 3 to infinity. Now, since we can see that the range of f is not the subset of domain of f, therefore f squared does not exist. That's for part C. Part D. The domain of f is further restricted to x is less than or equals to a, where a is a constant. State the greatest value of a such that the function f inverse exists. Now, I've written the value here, x is less than or equals to a, so let's check the graph over there. We need a 1, 1 function. So we can have this part of the graph right up to this point where you will pass the horizontal line test. So the value that I have for a will be this number here. So a must be equals to -2. Part E, hence find f inverse of x and state its domain. Now let's take a look at this modulus function over here. I will need to decide if I'm using y equals to 2x plus 4 over 3 minus x to arrange subject and get the inverse, or I will be using the negative of this function over here and arrange the subject to get the inverse. In order to decide, I'm going to go to the GC and I'm going to plot these two graphs out. So I'm going to plot the first one and the second one. And let's see the graph. What I need is the graph at this position here. So I can see that the red one that I have plotted is this version here. So for x less than or equals to -2, we are using this version. Let me just multiply the -2 to the bottom. So I have 2x plus 4 divided by x minus 3. Rearranging the subject, multiply this over xy minus 3y equals to 2x plus 4. Putting x term to the left hand side and y to the right. factorize our x. And last step, x will be equals to 3y plus 4 divided by y minus 2. So therefore, inverse function of x will be equals to 3x plus 4 divided by x minus 2. Okay, so I will still need to write down the domain of this inverse function. So the domain of the inverse function, let me just write it over here. The domain of the inverse function will be equal to the range of the function f. So looking at the function, I will be having 0 to 2 as the answer. So we're going to look at the range here from 0 to 2. That's all for part E.
Okay, let's take a look at question number 8. And in part A of question number 8, we are given z to be equal to -1 plus square root of 3i. And we are required to convert this into the Euler form. And I think the first thing that we should definitely do is to try to draw a point that is on the Argand diagram that represents this. And that point will have a coordinate of -1 and square root of 3. So if I can just reference this back to the origin using a right angled triangle that is like this. This is like -1 here, and this is like square root of 3 here. So the modulus of z, which is going to be this distance, by using the Pythagoras theorem, is going to be square root of 3 square plus 1 square, and this is going to be square root of 4, so this is going to be equal to 2. As for the argument, it's going to be this angle. So for the argument of z, we are going to take the full 180 degrees of pi minus away this angle here. And that angle is going to be tangent inverse of square root of 3 over 1. So this is going to be equal to pi minus away, this is pi over 3. So we will have a 2 pi over 3. So z is going to be equal to 2e to the power of I, 2 pi over 3. And this is for part 1 of the question. As for part 2, we are going to be looking at z to the power of n over iz conjugate. And the question says that this is a purely imaginary number. And based on this information, we are going to try to find the smallest positive integer value of n, which is here. So we are going to make use of the Euler form for z and try to convert this entire expression here to like individual Euler forms so that it's easier for me to combine them together. So this z is going to be 2e to the power of I, 2 pi over 3, the whole thing to the power of n. And this z is going to be 2e to the power of minus I, 2 pi over 3. As for I, it is in the Cartesian form. So for I, we should also try to convert it. Okay, doing a quick sketch of it on an Argand diagram, I is going to be represented by a point 0, 1. So the distance is 1 and the argument is pi over 2. So I is going to be 1 time of e to the power of pi over 2. So this is e to the power of I pi over 2. So we have a 2 to the power of n divided by 2. So 2 to the power of n minus 1. And we will have a e to the power of I. Here we will have a 2n pi over 3 minus away pi over 2 minus become plus 2 pi over 3. So this is going to be 2 to the power of n minus 1 e to the power of I times of, this is 2n pi over 3 plus pi over 6. And the question says that this is purely imaginary. And I think it will be way easier for us to analyze a complex number that is purely imaginary if we were to try to now re-express this back into its Cartesian form. And that is going to be this, then cosine 2n pi over 3 plus pi over 6 plus I sine 2n pi over 3 plus pi over 6. And since the question says that this is purely imaginary, if it is purely imaginary, that means the real portion, this is going to become a 0. So that is what I am going to try to do. I'm going to let the real portion of z to the power of n over I z conjugate to be equal to 0 in order for this expression here to be purely imaginary. And the real portion of this will be 2 to the power of n minus 1 cosine 2n pi over 3 plus pi over 6. This is equal to 0. So, I mean, this can be cancelled, so because this is always going to be positive. So we have cosine of this is equal to 0, which means that this angle here, if cosine of an angle is equal to 0, then this angle will be odd numbers of pi over 2, because pi over 2, cosine pi over 2 is 0, cosine 3, pi over 2 is 0, cosine 5, pi over 2 is going to be 0. So this is going to be of a format 2k plus 1 odd numbers of pi over 2, where k are any integer values, making n the subject. N here is equal to 3 over 2, k plus 1 over 3. And one more thing that we need to do in order for us to get the smallest positive integer value of n is to maybe just write down all the possible values of n. Okay, then we can sort it out. So to write down all the possible values of n where k is an integer value, I can either manually do the substitution, or you can basically just use the calculator to do the substitution. It's going to be way easier. So I've already planted this into my calculator over here. So in y1, I press in 3 over 2 x plus 1 over 3. Okay, then when I generate the table, I will be sorting out all those integer values. So y1 will represent n that is here. So y1 is minus 1, 2, 5, 8, and so on. Okay, so we have multiple values of n, and this is going to be minus 1, 2, 5, 8, and so on. And definitely we are going to be choosing 2 because we are looking for the smallest positive integer value of n. So therefore, smallest positive integer value of n is going to be equal to 2. This is for part B. Let's move on. Let's move on and take a look at part. Sorry, this is for part A and part 1, part 2. Let's move on and take a look at part B together. So for part B of this question, we are going to try to find the complex numbers v and w that satisfy the simultaneous equations that are given to me. We have a 2v plus modulus of w is equal to 1, and 3v minus iw is negative 3 plus 4i. Actually, based on the two equations that are given to us, right, we already know what v is. Okay, we don't know what v is, but we know the nature of v. V should be a real number, right? Because v is going to be equal to 1 minus modulus of w. Modulus of w is a real number. So 1 minus modulus of w divided by 2. So v is, we are expecting, okay, to be a real number. So if all my calculations are correct, then I should be getting a real number for v. And in order for me to solve this, I think I'm going to try to make v the subject for this and substitute back into here. So if I were to make v the subject, v here is going to be equal to half minus half modulus of w. I'm going to call this equation number 1, and this will be equation number 2. I am going to substitute equation number 1 into equation number 2, giving me 3 times of this. So we will have 3 over 2 minus 3 over 2 modulus of w minus iw is negative 3 plus 4i. And I don't think I can do much with an equation that is like this, because it is one single equation, but there are two unknowns. Modulus of w and w, they are different. Okay, that is why we have two unknowns. And I guess this is a good time for us to try to work on the fact that these two unknowns, they are actually related. They are related by the same format. So if I were to just let w be equal to, let's say, a plus ib, then we will have 3 over 2 minus 3 over 2 modulus of a plus ib minus iw is a plus ib. This is negative 3 plus 4i. So we will have 3 over 2 minus 3 over 2 modulus of this complex number is going to be square root of a square plus b square minus ia plus b. This is equal to negative 3 plus 4i. So we will have 3 over 2 minus 3 over 2 square root of a square plus b, which is going to be the real portion of the left-hand side. then minus IA is negative 3 plus 4i. Immediately we can just do a comparison and know that A is going to be equal to 4. Okay, this is pretty fast, and in order for us to solve for B, we are going to, oops, this is a minus. So minus IA, so minus A is going to be equal to 4. So A is going to be equal to minus 4. So with this, we are going to try and match this to negative 3. So 3 over 2 minus 3 over 2 square root of A square, which is going to be minus 4 square, plus B square, plus B, this is going to be equal to negative 3. So minus 3 over 2 square root of 16 plus B square is going to be equal to negative 3 minus 3 over 2. This will be a minus 9 over 2, then minus B. I'm going to multiply this throughout by minus 2, so it will be 3 square root of 16 plus B square is going to be equal to 9 plus 2B. Okay, let me square both sides, which will give me a 9, then 16 plus B square. Squaring both sides for the right hand side, it's going to be 81 plus 36B plus 4B square. Moving everything over to one side, we will have a 5B square minus 36B plus 63 is equal to 0. Solving for B, B is either 21 over 5 or B is going to be equal to 3. And now with these values of A and B, we already know what is the values of W for the simultaneous equation. So therefore, the possible values for W, where W is A plus IB, will be a minus 4 plus 21 over 5i, or W can also be a minus 4 plus 3i. We need to work out the corresponding value for V, so let me start with this. So when W is minus 4 plus 21 over 5i, then V is going to be, let's substitute into equation number 1. V is going to be equal to half minus half modulus of minus 4 plus 21 over 5i. So this is half minus half square root of 4 square plus 21 over 5 square. Working this out, we will have a real number, okay, according to what we have expected previously. So V is going to be equal to negative 12 over 5, real number. The other one will be when W is equal to minus 4 plus 3i. So V is going to be equal to half minus half modulus of minus 4 plus 3i. This is going to be half minus half square root of 4 square plus 3 square. This is going to be equal to negative 2. Okay, this is question number 8B. Let's move on. The next one is a vectors question. Okay, now let's take a look at question number 9, which is a vectors question. And in this question, we have the line L1. And for this line L1, it contains point A, and it is parallel to the vector that is given to us. So L1 will look like this. R is equal to, it contains point A, so negative 3, 1, 2. And it is parallel to 2, 1, A. And it contains the line L2 with the Cartesian equation of L2 that is given to us, and equating the entire Cartesian equation to, let's say, mu, re-expressing it into the vectors equation. So L2 will be minus 2, 1, 5 plus mu of 3, 2, 1. Okay, L2 is this. Let's try to work on part A to find the values of A and B when we are given that L1 and L2, they are going to be intersecting at point B. So if they were to be intersecting, that means at point B, this can be equated to this. Okay, so at point B, if I were to equate this to this I am going to write it as minus 3 plus 2 lambda, then 1 plus lambda, then 2 plus lambda A. Is going to be equal to minus 2 plus 3 mu, 1 plus 2 mu, and 5 plus mu. So from the first row, we will get minus 3 plus 2 lambda is minus 2 plus 3 mu. This gives us our first equation, 2 lambda minus 3 mu is equal to 1. From the second row, we will have 1 plus lambda is 1 plus 2 mu. This gives us our second equation, lambda minus 2 mu is equal to 0. This is equation number 2. And from the third row, we will have 2 plus lambda a is equal to 5 plus mu. This is going to give us our equation number 3, but just with equation 1 and 2, we can already press it into our graphing calculator to try to solve this pair of linear simultaneous equations. So let's try to solve it first. So from our graphing calculator, solving for equation 1 and 2, lambda is going to be equal to 2 and mu is equal to 1. That is why, based on this, if I can just make a the subject for this equation a, which is going to be 3 plus mu over lambda, so we can already solve for a by substituting these two values back into here. So it's going to be 3 plus 1 over 2. A is going to be equal to 2. And if a is equal to 2, to find b, b is the intersection between L1 and L2. And for the intersection, lambda is equal to 2, mu is equal to 1. I'm going to just sub it back into here. Mu, I'm going to sub 1 into here to find OB. So therefore, OB is going to be minus 215 plus mu, which is 1 times of 3 to 1. This is equal to 136. So the question asks for the coordinates of BB will be 136. Let me bring this information back to here because we are going to be using it. So A is going to be equal to 2. Let me just rewrite this. This is 2. And we know that this is the position vector of A. And we also now know another piece of information, which is point B has a coordinates of 136. Okay, I've jotted down this. Let me move on to part B of this question. So for part B, which has two parts, let's look at it, part B. So for part B, part 1, we are going to be analyzing the shortest distance from point B to the plane pi 1. And according to the question, for the plane pi 1, let me just draw out a simulation of pi 1. For the plane pi 1, it contains point A. So this is, let's say, point A, which has a coordinate of minus 3, 1, 2. And according to the question, it is perpendicular to L2. So I don't know where is L2. Let's say L2 is here. So it is going to be perpendicular, okay, to pi 1. So if it is perpendicular to pi 1, that means the vector that is parallel to L2, which is this 3, 2, 1, is going to be perpendicular to pi 1 also. That is why for pi 1 over here is going to be, if I were to write the dot product equation of pi 1, its normal vector can be this 3, 2, 1. And since it passes through, or rather A lies on pi 1, so I'm going to just substitute and replace this R by negative 3, 1, 2. So this dot 3, 2, 1, this is equal to minus 5. This is the dot product equation of pi 1. And in order for us to find the shortest possible distance between B and pi 1, I'm going to use the same strategy as what I've discussed on the Achevas TV, which is, let me just draw out point B first with a coordinate of this, the distance between B and pi 1. Let's say this is pi 1. To find this perpendicular distance, what we will do is we will construct another plane that is going to be passing through point B, and it is going to be parallel to pi 1. I'm going to call this plane pi B. So the equation of this plane pi B will be, since it's parallel to pi 1, it can share the same normal vector. And since it passes through point B, then I'm going to just replace this R by 136. So this dot 3, 2, 1. And this is equal to 15. So the shortest possible distance that is required by the question, which is the distance between b and pi 1, can be calculated by going for a modulus of 15 over modulus of 3 to 1 minus away for pi 1 is this minus 5 over modulus of 3 to 1. Okay, this is in accordance to the same strategy and formula that we have on Achevas TV. So it is going to be equal to the modulus of 15 minus this is going to be 20 over square root of 3 square plus 2 square plus 1 square. So we have this as a 20 over square root of 14. Okay, so now this is the shortest possible distance. Let me indicate it on the diagram here. This is the shortest possible distance from b to pi 1. This is 20 over square root of 14. Because part 2 actually is a bit interesting because of the hence. The question says hence we want to find the acute angle that is between L1 and pi 1. And to find that acute angle, making use of what we have found so far, okay, which is this 20 over square root of 14, which is the shortest distance between b and pi 1. Let me erase this so that we can look at just b. So there's some things that we know so far. The angle between L1 and pi 1, which is definitely this we are going to be making use of. And L1, right, actually will be passing through point B. Because according to what we have discussed previously, the intersection between L1 and L2 is point B. So B must be lying on L1. And in fact, point A, according to what the question says, A also lies on pi 1. So let's say point A is here. So L1 is actually going to be a line that passes through this. And the angle is actually this angle. So as long as you can find the value of this angle, it is going to be the angle that is between L1 and pi 1. We already know this distance. Another distance that we also can find out very easily is the distance AB. So I'm going to find vector AB first, which is going to be OB 136 minus away OA, which is going to be minus 312. And this is equal to 4 to 4. So modulus of AB is going to be square root of 4 square plus 2 square plus 4 square. This is equal to square root of 36, and that is going to be equal to 6. So we know from here sine theta, if theta is the angle that is between L1 and pi 1, sine theta is going to be opposite, so 20 over square root of 14 over hypotenuse. Hypotenuse we have just found, this is 6. So this is over 6, which means that theta is going to be sine inverse of 20 over square root of 14 over 6. Pressing into our calculator, this is going to get us an angle of 63.0 degrees to 1 decimal place. Okay, the last part, we are going to be looking at the plane pi 2. Let me erase this first. So this, and according to the question for this plane pi 2, it is perpendicular to pi 1. Let me just do a quick sketch for this part C. So it's like maybe something that is like this. Okay, if I were to call this pi 2 and if I were to call this pi 1, they are, first of all, perpendicular to each other. If they were to be perpendicular to each other, then the normal vector from pi 1, which is the normal vector from pi 1 is this 3, 2, 1. The normal vector of pi 1 will be parallel to pi 2. And the question says also that this plane pi 2 contains L1. So let's say this is our L1, which means that the vector that is going to be parallel to L1, which is 2, 1, 2, will also be parallel to pi 2. And the points that are on L1, which we have 2 points, one is point A, one is point B. Let me just use point A. So it will be minus 3, 1, 2, which is a point that is on L1, will also be a point that is on pi 2. So with one vector that is parallel to pi 2 and another vector that is parallel to pi 2, the normal vector can be found by taking the cross product of these two vectors that are parallel to pi 2. and this is going to be 3 minus 4 minus 1. So for pi 2, it will be r dot 3 minus 4 minus 1. I'm going to use this point, so it will be minus 312 dot 3 minus 4 minus 1. This is equal to minus 15. So the Cartesian equation will be us replacing this by x, y, z. So this dot 3 minus 4 minus 1 is minus 15. The Cartesian equation will be 3x minus 4y minus z is minus 15. Okay, done. The next question, question number 10. Let's take a look at question number 10. And in part A, we are going to try to show that dm dt is equal to that expression. So m is Andrew's mass, which means that dm dt will be the rate of change of Andrew's mass. And if I were to look at this system, we will be able to read from the question, rate of input and rate of output pretty clearly. The question says that the mass is going to be according to here. The rate of change of a person's mass is going to be proportional to the difference between energy intake and energy expenditure. And energy intake for Andrew, it is going to be fixed at C calories per day. So the rate of input is going to be C. And for the rate of output, it is going to be the energy expenditure. And for his energy expenditure, it's going to be 30 calories per day per kg. And Andrew is mkg. That is why the rate of output is going to be 30 multiplied by m. And according to what the question says, the rate of change of a person's mass is proportional to the difference between the energy intake and the energy expenditure. So it's going to be proportional to C minus 30m. So replacing this notation by a constant of proportionality, we can then say that dm dt is going to be equal to k times of C minus 30m. Yep, and this is what the question requires us to show in part A. Let's move on. Let's take a look at part B. Part B, we are given that Andrew's initial mass is 110 kg. We want to find the energy intake. Energy intake is C. So we want to find the value of C, that he maintains his mass at 110. When the question says that he maintains his mass, that means there's not going to be any change in his mass per unit time. And that will mean dm dt is equal to 0. So when m is maintained at 110, we are going to let dm dt be equal to 0. So this is going to be equal to 0. K times of C minus 30m is equal to 0. And m here is going to be 110. So K times of C minus 30 multiplied by 110 is equal to 0, which means that C over here is equal to 3300. This is the answer for part B. Let's move on. In part C, as part of a new health plan, Andrew fixes his energy intake at 80% of the value that is found in part B. So for part C, we are going to be letting the energy intake to be 80% of this. So it's going to be 0.8 multiplied by 3300. So the energy intake is going to be equal to 2640. Okay, so with this, we are going to try to solve the differential equation showing that Andrew's mass while he is on this plan is going to satisfy this equation over here. So we are going to substitute C into here, and let's try to solve this differential equation. Okay, so dm dt is going to be k times of C, which is 2640 minus 30m. And to solve this differential equation, I recognize this as a variable separable format. So I'm going to divide this across to the other side, giving me a 1 over 2640 minus 30m dm dt. This is equal to k. And then integrating both the left and the right hand side with respect to t. On the left hand side, it is going to be 1 over 2640 minus 30m dm. On the right hand side, k is a constant. I'm going to take care of the integration notation, leaving me with integrating 1 with respect to t. And this is going to be minus 1 over 30, then ln modulus of 2640 minus 30m is equal to kt plus an arbitrary constant. I'm going to go for a to be the arbitrary constant. So for this that we have here, I'm going to try to make m the subject. Okay, so to do that, I will rewrite this. 2640 minus 30m is going to be equal to negative 30 kt negative 30a, which means that modulus of 2640 minus 30m is going to be equal to e to the power of this, which I'm going to break up the power into two different parts. So I'm going to go for this first, so minus 30a, then e to the power of negative 30 kt. Removing the modulus on the left hand side. On the right hand side, I'm going to just replace it with a plus minus. So 2640 minus 30m. This is going to be equal to plus or minus e to the power of negative 30a, e to the power of negative 30 kt. So based on this, I'm going to rewrite. So we have this minus 30m. I'm going to rewrite this as another arbitrary constant. I'm going to go for b. So b e to the power of negative 30 kt, where this b here represents plus or minus e to the power of minus 30a. So with this, I'm going to actually try to solve for b first, because I do see a possibility of making use of this piece of information here. Okay, Andrew's initial mass is 110 kg. Okay, so I'm going to make use of that, which means that when t is equal to 0, we know that the mass is 110 kg. So substituting this set of information into here, we have a 2640 minus 30 multiplied by 110 is going to be equal to b e to the power 0, which is going to be 1. So we know from here b is going to be equal to negative 660. So if I were to replace b by this, then we have a, let me write it down here, we have a 2640 minus away 30m. This is equal to negative 660 e to the power of negative 30 kt. And with this, I guess we can make m the subject. M is going to be equal to 88, then plus 22 e to the power of negative 30 kt. Okay, and this is actually what, this is actually what the question requires us to show. So done for that part. Next, let's look at part D. Part D, we want to find the additional number of days that is required for Andrew's mass to fall below 96 kg. We're actually given another set of information, which is when t is equal to 75, m, Andrew's mass is equal to 100. So I think what I'm going to try to do is to try to solve for the unknown k first, so that I can later on try to find what is the time when Andrew's mass falls below 96 kg. So in order for me to do that, let's make use of this new piece of information, which is when t is equal to 75, m is equal to 100. Okay, so it will be 88 plus 22 e to the power of negative 30k times 75. This is going to be equal to 100. We will be able to solve for k. But with a bit of observation, I think we can do better than just simply trying to solve for k, because, let me just show you something. Because I can see that from what that is for here. Okay, let me analyze this expression, okay? Our aim is to try to make this k into a number. But what if I were to try to re-express this as m is equal to 88 plus 22 e to the power of negative 30k, then the whole thing to the power of t. This actually saves me a little bit of time to try to re-express k in the form of a number. But we can re-express e to the power of negative 30K, so that maybe it is a little bit shorter. My whole process is a bit leaner. Then this is what I mean. That means based on this, right, it is going to be, if I were to just try to rewrite this, I will be able to rewrite this as e to the power of negative 30k, then multiply by 75 here. If I were to move this over, 100 minus 88 divided by 22, it gives me a 6 over 11, which means that e to the power of negative 30k is going to be 6 over 11, the whole thing to the power of 1 over 75. And this makes it easier for us to now re-express this. Let me do it here. So if I want to re-express that, we just need to now try to change this into just simply an e to the power of negative 30k. So based on this, therefore, m is equal to 88 plus 22, rewriting this as e to the power of negative 30k to the power of t. Then I'm going to just replace this by this. So it is going to be 88 plus 22. Here it will be 6 over 11 to the power of 1 over 75. And this is going to be to the power of t, which means that m is going to be 88 plus 22, 6 over 11 to the power of t over 75. You know, my whole process is a bit leaner, and I like it this way. So based on this m that I found, I'm going to let m be less than 96 according to what the question says here. Okay, then I can find the additional day such that his weight is going to fall from 75 all the way until this fall from his current weight all the way until this 96. So from here, if I were to just continue, I'm going to let m be less than 96. I want to find out what is the additional number of days that will take him to go from 100 kg to 96 kg, to be less than 96 kg. So I'm going to replace m by this. So we have an 88 plus 22, then 6 over 11 to the power of t over 75. I'll let this be less than 96. We can definitely try to solve for t in this inequality, or we can just simply press the left-hand side into our graphing calculator and generate a table for it. So if I were to press this into my graphing calculator and I generate a table for it, my calculator will give me different values of t versus the total mass, which is this. I'm going to just write it as m. So m is this on my calculator. If I were to scroll down the table in my calculator, when it is 125 days, the mass is 96.011. When it is 126 days, the mass is 95.947. So this is when the mass first fall below 96 kg. And one more that I'm going to write will be after this, it is going to continue to be below 96 kg. So therefore, we know that when it is during the 126th day, Andrew's mass is going to fall below 96 kg. So the question asks for the additional day. Let's not be tricked. Okay, the question didn't ask for which day his mass is going to fall below 96. The question asked for the additional day. So if we started off at day 75, so the additional day will be 126 minus 75. My answer here is 51. Okay, we are coming to the end of the question, and I'm actually doing it from the right to the left, but that's okay. I will still need some of the results that I've written on the board, so I'm going to leave it there. And in part E part 1, we are supposed to sketch a graph where it is going to be plotting Andrew's weight versus the time for this particular plan. And we want to explain why Andrew can never achieve a mass that is going to be 80 kg using this plan. So using this plan, so we're going to be sketching that. So sketching for E part 1, sketching for m to be equal to that, which is 88 plus 22 e to the power of, actually this is e to the power of, so I'm going to remove this. I'm going to be replacing it by this. So 6 over 11, then t over 75. So sketching this on my graphing calculator, it is going to give me a decreasing graph starting from t is equal to 0. And the decreasing graph seems to be decreasing to a constant value. And we can also see it from here. When t goes to infinity, m is going to go to 88. So the graph will have a horizontal asymptote, m versus t. And this horizontal asymptote will happen at m is equal to 88. And my graph is going to be something like this, tending towards 88. It is going to be starting from here, and this is his initial mass of 110. So looking at this graph, I'm going to just say out my explanation, okay? So looking at this graph, we can see that as t tends to infinity, m is going to tend to 88. And before this, there will be no time when the mass falls below 88, which means that it is not possible for Andrew to achieve a mass of 80 kg using this plan. Okay, so that will be my explanation for part 1's second part. And for part 2, we want to state the range of possible values of energy intake for which Andrew could achieve a mass of 80 kg. This will require us to actually think of the entire process that we have tried to calculate for this second plan. Because if you were to look at, let's say here I think it's a good start. The energy intake is actually this value here. Okay, this was the C, and that became 88, which means that this 88 over here was a 2640 over 30. Okay, that gives us this 88, and this 88 is going to become here. So which means that if Andrew were to try to achieve a weight of 80 kg, right? That means we need to make sure that this number becomes 80 instead. Okay, so if this were to be happening, then we want to make sure that this, we are not going to be using this anymore. We're going to replace this by the energy intake, which is going to be replaced by C over 30, because 2640 was the energy intake that we used previously. So for part 2, inferring from what we have just discussed, I am going to let this number be changed to C over 30 instead of 2640 over 30. Okay, so I'll let this be equal to 80 kg, so Andrew's mass can fall to 80 kg. So based on this, the energy intake here is 2400. So therefore, the required, according to the question, the required range of possible values of C, which is the energy intake, in this case, C should be less than 2400, but at the same time, the energy intake must be positive. So I'm going to let this be bigger than 0 also. Okay, this is going to be for our question number 10. Okay, let's take a look at question number 11. And in part A, we are going to try to find the smallest possible value of A, where A is the amount of initial deposit that Wei is going to make into this account, where she's going to be trying to save at least $50,000. So according to what the question says, the very first deposit, which is on the 31st of January 2021, Wei is going to deposit A, and in every subsequent month, she's going to be depositing $50 more than the previous. So for the first month, let's say U1 is going to be this. For the second month, it is going to be A plus 50, and for the next month, it's going to be 50 more than the previous, so it'll be this plus 50, then it will be 50 multiplied by 2. So from one term to another term, it is going to be a constant increment of 50. So what we are seeing here is an arithmetic progression. Let me write it down. So we are seeing an AP where the first term is A, and the common difference is going to be 50. And we are talking about her trying to save for all the way from the 31st of January 2021 all the way until 31st of December 2023. This is 3 years. So the number of terms will be the number of months. So it's going to be 12 months times 3 years. So this is going to be equal to 36. So in order for us to find the smallest possible value of A such that she will be saving at least $50,000, we will be doing a U1 plus U2 plus U3 all the way until U36. That will give us the very, very last month. We are going to let this be bigger or equal to $50,000. So she will save at least $50,000. So which means that we are talking about a S36 for an AP to be bigger than $50,000. And applying the sum of AP formula from the first term all the way until the 36th term, it is going to be the number of terms, 36 divided by 2. Then 2 times of the first term, which is A, plus the number of terms minus 1 times the common difference, which is going to be 50. This will let it be bigger or equal to 50,000. And if you have to work out for the value of A in this inequality, A is going to be bigger or equal to 513.89, which means that the smallest, let me write it out, that means the smallest possible value of A is going to be equal to 513.89. Okay, this is for part A. Let's move on. Let's take a look at part B. Okay, now in part B, Wei is going to be buying her property. So on the 1st of January 2024, Wei will take up this loan of $400,000, where the loan will be such that an interest of 0.1% is going to be added at the start of every month. And the very first month that this will start, according to the question, will be that month when she borrows the money from the bank. So it will be on the 1st of January 2024. And by the end of the month, Wei will be consistently paying back X amount of dollars. And she will be doing so again in that very first month when she borrows the money. So for part B, if you want to show that expression, which is going to be the amount of money that she owes at the end of the nth month, I think what I'm going to do is to try to look at the trend that is ongoing by writing down what that is happening on a little table for myself. So I'm going to work on the month that she's going to be borrowing and repaying the money, and versus the amount of money that she owes, amount that she owes at the end of the month. So according to what the question says, during the first month, she will be borrowing $400,000, and the bank will impose a 1% interest. So this will happen in the beginning of the month, and at the end of the month, she will return back X amount. So this minus away X. And this will continue to go on for every subsequent month, and of course until when she managed to repay back her entire loan. So for the second month, it will be starting off with this, and the bank will be imposing a 1% interest, and she will be returning X amount again. Okay, so rearranging this, I will be going for this 400,000 multiplied by 1.001 square. Then I'll put all the x's together. So it will be minus away x. Then here will be plus 1.001x. Okay, this will be for the second month. And for the third month, I think I should be able to see a pattern. In fact, I'm already seeing some pattern over here, but let me just write down one more month. So in the beginning of that month, we are looking at this, which is this times 1.001 square minus x plus 1.001x. And the bank will impose a 1% interest, and then she will return back X amount. So if I were to just reorganize this again, we have a 400,000 times 1.001 times 1.001, so this will be to the power of 3. And putting all the x together again, we will have an x. Then this times this, it is going to be 1.001x. This times this, it will be 1.001 square x. Okay, and this should be sufficient for me to guess what is going to happen during the nth month. Because for the very first term here, we are seeing 400,000 times this to the power of 1, 400,000 times this to the power of 2, it will be this to the power of 3, which means that for the nth month, it is going to be 400,000 times 1.001 to the power of n. And that is good because it's giving us our very first term here. As for this, we are seeing this as a GP, a geometric progression. Because this over here, to me, it is a sum of a GP, where the first term is x, and the common ratio is 1.001. Okay, so based on this, I'm going to apply the sum of GP formula. It is going to be the first term, then 1.001 common ratio to the power of number of terms. Let's count. For the first month, 1 term. Second, 2 terms. Third, 3 terms. So nth, there should be n number of terms, minus 1 over 1.001 minus 1. So this will be equal to 400,000 times 1.001 to the power n, minus away this, if I can just re-express, it will be 1000x, then 1.001 to the power n minus 1. And this is exactly what the question requires us to show. Next, C. Let me write it here. C, part 1. Suppose that this loan is supposed to be repaid in 360 monthly repayment. That means n is going to be equal to 360. We want to find the value of the monthly repayment, which is x. Okay, we want to find x when the loan is completely paid for after 360 monthly repayment. So we are going to replace this n here by 360, and we are supposed to find x when this entire thing, I'm going to let it be less than or equal to 0 for the loan to be fully paid for. So we are going to let the amount that is owed by the end of the month, and we are talking about the end of the 360 month, so 1.001 to the power of 360 minus 1000 times x, then 1.001 to the power of 360 minus 1. I'll let this be less than or equal to 0. A simple inequality with x as the only variable. So x is here going to be bigger or equal to 1323.63477.6, which means that the monthly repayment will be $1323.63 for part 1. Part 2, C part 2, we want to use this answer to calculate the total interest that is paid on the loan in this case. The total interest that is going to be paid. So to calculate for that, the total interest that is going to be paid, we'll be making use of this, and 360 payments have been made. So it will be this 1323.63 times 360. But this will be the amount of money that Wei pays to the bank. We must offset the amount of money that she borrows from the bank. So this will be minus 400,000. This will give us the interest. The interest is going to be 76506.80. Okay, so this is going to be for C part 2. Let's move on and take a look at D part 1. D part 1. So for D part 1, now Wei is going to be going for another version of repayment where the rate of repayment per month is 1,600, which means that we are looking at x to be equal to 1600. We want to find out the value of k, where according to the question, it is defined for us that k is the number of months that she will be paying back 1,600. But we don't want to assume that this will be the total number of months where she will be repaying the money. Okay, because especially when the question actually told us that it is possible that for the very final month, the amount of money that is paid back is different from 1,600. Because according to what the question says, we are supposed to find y, where y is less than 1,600. So she'll be paying back 1,600 for every month, maybe except the very last month where she's owing less than $1,600 already. That's why definitely she's going to be paying back another value, okay, as the loan repayment. So let's try to find out about this by, again, letting this be less than or equal to 0 for the loan to be fully paid for. But we are going to be letting x be replaced by 1600. So we are going to let this, which is 400,000 times 1.001 to the power of n minus 1,000 times x, which is now going to be replaced by 1,600, then 1.001 to the power of n minus 1. We will let this be, once again, less than or equal to 0. And to try to analyze the situation, I think one of the best way for us to do that is to plug this into our calculator and let our calculator generate for us a table for different values of this, for different values of n. So based on what I can get from my calculator, generating a table where we are looking at the n repayment and the amount of money that is owed at the end of the month. So amount that is owed at end of month. Okay, and let's not forget that this is actually this expression. Okay, so this is this. So if I were to scroll down my calculator, these are the values that I'm going to be seeing. When n is 286, here is going to be 2917.3. When it is 287, then here is 1320.2. When it's 288, here is negative 278.5. And let's not forget also that what we are seeing here are money that is the amount of money that is owed at the end of the month. And this happens after the repayment, right? This happens after the repayment X, which means that in this month and all the months that are prior to this, she'll be repaying back $1,600. Then this will be the value that is owed. So the same goes for this, $1,600. Then this will be the money that is owed, which means that in this month from this month onwards, the amount of money that is owed, okay, not onwards, but from this in this month, 288 month, when n is equal to 288, the amount of money that is owed is already less than $1,600. So likely that is going to be the last month of the repayment. So most likely that last month is going to be the y that we are calculating. But as of now, we already get one of the answers, which means that in this case, k is going to be equal to 287. Okay, this will be the number of repayments that she will be paying back $1,600. So we do want to be careful about this. And as for the amount of money that is repaid back during the very last month, this will be the very last month. That will be not this amount, because she will only be paying back at the end of the month, which means that in the beginning of the month, she will already be charged the interest. So the amount of money that she will owe will be this 1320.2. But if I were to look at the calculator, let's make use of more significant figures. So if I were to go for the number that is given to me in the calculator, it's going to be 179912. So we will go for the value with the interest to give us the amount of money that she is going to be owing, which is going to be 1321.54. Okay, this is D part 1. And finally, we are going to be working on the very last part. Let me go for D part 2 using this space over here. So for D part 2, we are going to try to compare the two different schemes, the two different repayment methods. So we are going to compare D with C. For C, we are going to be looking at the interest to be this, okay? And what we are interested in, okay, what a pun. So hence we want to find the total savings. So which means that for C, scheme C, this is the amount that she will be paying for in order for her to be borrowing $400,000. So we want to know also the amount of money that she will pay for if she were to be using the second scheme here. Then by looking at the difference, this should give us her total savings. So let's look at the total interest that is paid for this scheme. Okay, so total interest, I'm going to calculate it, but this time is for the second repayment method. Let me just write down second method. Okay, this will be the first method, and the interest paid is going to be this. So for the second method, we are seeing her paying $1,600 for 287 times. So I'm going to write down this 1600 multiplied by 287. Then plus this very last month where she's going to be paying this amount. So it's going to be added to this 0.1320 plus 20. This is 0.217991 times 1.001, which is actually this. And this is the amount of money, this is the total amount of money that she is going to be paid back. And just like what we have done here, we must offset the amount of money that she borrows. So minus 400,000. So this will give us the interest. So this is the amount of money that she pays minus away the amount of money that she borrows. This will give us 60521.53821. So this is the interest. For the second method, it is obviously less interest than this. So the total savings that she is going to be getting, I will take this amount, which is 76,508.51936 minus away this 60521.53821. So the savings will be to 4 significant figures. This. Okay,